Hi, this is Tim Hsu from San Jose State University, and I'm here to talk about applications of rates of change. So after briefly going over the goals of this video, I'll talk about rates of change in physics, how to interpret rates of change in terms of economics and business, and then in some other subjects as well. Okay, just to recap before going over the goals of this video, that you can interpret the derivative in the following ways. You should have seen these already at this point. So for example, if f is thought of in terms of the graph y equals f of x, then one interpretation of f prime of a is that it's the slope of the tangent line at x equals a. Next, if f represents the position of some object at time t, f of t, then f prime of a represents the instantaneous velocity of that object at time t equals a. Or just to generalize both of those, if f represents any function, then f prime of a is the instantaneous rate of change, ROC is an abbreviation for rates of change, at x equals a. And so really, if you think about it, all you really need to know is that last line. And in some sense, you could just take that last line, that f prime of a is the instantaneous rate of change of f at x equals a, and go forth and do all the problems that are applications of the derivative. Okay, bye! No, well, okay, so you probably want a few more details and examples, so we'll go on and do that. That is, to be specific, what we'll do in this video is that we'll discuss a list of different interpretations of f prime in particular settings, and then it'll be up to you to use those interpretations to solve problems. So the point is, the trick is, don't get caught up in the details of any particular example, because memorizing one specific example is not nearly as useful as understanding the idea behind a general class of examples. So keep your focus on the big picture. If f is a function that represents some quantity, then f prime is the rate of change of that quantity. If f is a function, f prime is its rate of change. All right, so to start with physics, for example, if s equals f of t is the position of some object as a function of time t, then actually, as we were just saying, then v of t equals f prime of t is the velocity of that object at time t, and a of t equals v prime of t equals f double prime of t. So remember, a of t is the first derivative of velocity, or the second derivative of position. A of t is the acceleration of that same object at time t. All right, so yeah, so if f is position, f prime is velocity, and f double prime is acceleration. So another application comes from looking at electricity. So if Q of t is the amount of positive charge contained in a particular region, then I of t equals Q prime of t is the current, or in other words, the rate at which positive charge flows into that region. Turning to economics and business, in revenue/cost/profit economics, or in other words, business, often quantities are a function of x, the number of objects produced and sold. So here's what I mean by that. So for example, C of x might represent the cost of producing x objects, in which case C prime of x is the marginal cost, or approximately, of producing one more object than you have already produced. In a similar way, if R of x is the revenue obtained but when you sell x objects, then R prime of x is the marginal revenue, approximately, obtained from selling one more object. And if P of x equals R of x minus C of x, that is, profit equals revenue minus cost, business, there we go, is the profit made from producing and selling x objects, then P prime of x equals R prime of x minus C prime of x is the marginal profit, or approximately, made from producing and selling one more object than you had already. All right, turning to other rates of change, in biology, if n of t is the size of some population at time t, then n prime of t is the instantaneous rate of change of that population at time t. In chemistry, if bracket A is the concentration of some chemical in a reaction, then d bracket A dt is the instantaneous rate of reaction of that chemical in the reaction, and so on. If foo is some quantity, then d foo dt is its rate of change. You get the idea. The point is, and really, again, I can't mention too many times. The point is that every problem is different. If you want to do calculus in some useful way, that every problem you see will be different. And so the point is to keep the main idea in mind, that if f is a function that represents some quantity, then f prime is the rate of change of that quantity. All right, that's all for now. Go do something useful. Go do some problems. That's the whole point, right? Okay, thanks. Bye.